All right, so now we move on to our first lesson of sequences in series, and that's dealing with 1.1 arithmetic sequences. So for this one, what we're going to do is to start this up, we're just going to kind of look at a bunch of different patterns, and this kind of outlines the theme of the unit, which is we're going to look at ordered lists of numbers or terms, and we're going to determine whether they're arithmetic or geometric, which geometric we'll cover in the future, but for now we're going to deal with arithmetic, and we want to establish how patterns can then determine the rest of the list here. So in this startup, let's determine based on number one here, what is happening in the pattern and then fill out the rest of the terms. We go from 3 to 8, 8 to 13. That means we're increasing by 5 each. So when I increase each of these by 5, I'm going to go to 18 for the first one here. So let's just make that a little clear. There we go. We add 5 again, we get 23, and then we add 5 again, and we end up getting 28. So this completes that full sequence where we have 3 all the way to 28, and then we just stop there because that's all the terms they were looking for. Now, in number two, very similarly, we go from -8, -11, -14. Looks like we're decreasing by -3. So what we're going to do is we're going to make this -17, then -20, then -23. And that's us just subtracting 3 every time we go to that next term. Now, for our next one, we go from 1 to 3, 3 to 9, 9 to 27. Well, we can clearly see that we're just taking whatever term we had before and multiplying it by 3. So if we had 1, we multiply by 3, which gives us 3. If we have 3, we multiply by 3, and it gets us to 9. We're just going to continue that pattern. If I take 27 and multiply it by 3, I get 81. If I take 81 and multiply it by 3, I get 243. And then if I get 243 and multiply it by 3, I get 729. All right. Now going down to number four, we go from -2 to +4, +4 to -8. It looks like we're just multiplying them all by -2. So if I take -8 and I multiply it by -2, it gets me to +16. I take 16 and multiply it by -2, which gives me -32. And then if I take this -32 and multiply it by -2, I get 64. And we should see that pattern of negative, positive, negative, positive. It's just constantly alternating between the two because when we look at these, we're like, oh, okay, I just simply multiply them all by the -2. And when I multiply by -2, it gets me to that next term, and so on and so on. All right, now we're going to look at one that deals with the alphabet. So rather than just strictly number based, it's like, okay, well, what's happening in this sequence such that we get the next two letters in this sequence? And here's how I would do one like this. If it was given to you as just like variables or things that you're writing out in a sequence like this that aren't numbered based, we got to figure out what's happening between each of the letters such that we get the next letter here. Now, to help us out, what I'm going to do is I'm going to write out the alphabet. So I'm going to go like A, B, C, D, E, F, G, HIJKLMNOPQRS, and then from there, we could, I guess, write the rest, but I'm just going to maybe stop there because we may not even need the rest of them here. So in this first one here, from A to C, we realize that when I go from A to C, there is one letter between them. So I'm just going to write it as one L, or one letter exists between the two of those. Now, when we go from C to F, I'm going to use a different color to represent this. From C to F, we go an extra letter. Between these, there is two letters. Then when I go from F to J, F to J, I'm going to use this using another color. That means I go from here to here. I add one more letter between them. It's three letters of G, H, and I between the two. And then if I want to go to the next one, well, assuming this pattern is 1, 2, 3 letters between them, what I'm going to do is I'm going to go over 4 letters. So I'm going to start at J. Whoops, don't want to go from there. So I'm going to start at J and then put 4 letters between them. If I put 4 letters between them, that's going to put me over to O. And so this would be 4L. And now I can write that as the next letter in the sequence is O. But now for my final one, I'm going to put 5 between them. And so let's see if we can use maybe red again. I'm going to go from the O 5 letters over. And if I go 5 letters over between them, that means that I'm going to be here, which puts me to the U. So in a situation like this is a very rare situation where it might just help to like write out the whole alphabet because or else you won't be able to establish that pattern quite clearly. I mean, if you're really good just mentally thinking about how many letters are between or how many you're having to go to get to the next letter, you might be fine. But for me, I'm the type where I would like to visually see this written out, and this might help you too. All right, now we go to this next sequence here, which is 0, 1, 1, 1, 1, 2, and we see that it's just kind of going up in this pattern that's a little bit indistinguishable. This is actually called the Fibonacci sequence. So I would like you to write that off to the side. Fibonacci sequence. And the key to the Fibonacci sequence is when you look at how the numbers progress, you go from 0 to 1, 1 to 1, 1 to 2, they're adding the previous two numbers together. And here's what I mean by that. If you take 0 and 1 and you put them together, you end up getting 1. If you take 1 and 1 and put those two together, you get 2. If you take 1 and 2 and you put them together, you get 3. So you're just adding the previous two numbers. In this situation, if I want to get to the next number, I'm going to take 5 and 8, add them together, which gives me 13. So I can fill that into my next blank. If I want to get the next number, I take 8 and 13 and add them together, which would give me 21. And then I take 21 and 13 and add them together, and I end up getting 34. So the Fibonacci sequence is this sequence, which it then goes into the golden ratio and all this other stuff. But it's this idea that you're taking the previous two terms and adding them together, giving you this rapid expansion like this. Okay, now for our next one here, we have 11 and 35. And then we're like, okay, well, we want to figure out what this term is that goes between them. Well, here's how I would do this. If I was doing this type of sequence where I'm having two outside term or two inside terms, my apologies, that are missing, what I would do is I would take the 35 and then minus the 11. So you're taking the two outside terms and dividing them. And then I'm going to divide this by 3. Now, the reason I'm going to divide this by 3 is because I want to figure out what is the even divisible number that makes up all three of these terms that when put together would give me that difference between those two. And so you're kind of thinking about it as an average as a way to get these two middle terms in the middle here. Now, if I take 35 minus 11, this is going to be equal to 24. And then 24 divided by 3, this is going to give me a common difference between the terms of, we're going to get 8. So if I want to get my next two terms, I'm just going to simply add 8 to them. So 11 plus 8 gives me 19, 19 plus 8 gives me 27, 27 plus 8 gives me 35. There we go, perfect. We're right on the nose with this, and we have exactly the terms we're looking for here. So again, if you want to figure this out, it's kind of like thinking about it as you want to figure out the average that would represent the term difference between those, and then that will help you get that term. Now, when we go to number 8 here, what we're going to do is we're going to take -5, -15, -45. We clearly see that it's being multiplied by 3. So this one gets multiplied by 3, then it gets multiplied by 3 to the next term. So we're just going to continue that pattern, keep multiplying them by 3. This gives us -135. -135 multiplied by 3 is -405, and then we're done because there's no other blanks, so we're just going to leave it at that. Now, these are examples of a mix of arithmetic and geometric series, which we're going to, again, start with arithmetic, which is a very specific type of sequence. So first of all, we want to introduce some terminology along with this. A sequence is just an ordered list, just like the ones we were given above. It's an ordered list of terms or an ordered list of given objects, like the one that was in the alphabet. Each number in that sequence or each specific item in that sequence is called a term. And then the subscript n in this unit is just going to represent a specific number in that sequence. And then lastly, and probably most importantly, we're going to deal with this idea of a general term, which just simply represents an overall formula that allows you to get any single term in that given sequence. So let's see how this looks below, just dealing with this general term idea and the n and finding specific terms in this sequence. So write the first 5 terms of the sequence when it's defined by the general equation of this. Now, to do this, all we're just going to do is plug in 1, 2, 3, 4 for n and solve the given terms here. So I'm going to go t1 is equal to -2 times 1, which is the n value, minus 5. This is going to give me -7. I'm then going to go t2, which is equal to -2 times 2 instead of 1, minus 5. This is going to give me -9. I'm going to go to t3, which is equal to -2. The third term, which is the n, minus 5 is equal to, well, this gives me -6 minus 5, which is -11. And then clearly we see a pattern here, right? So I probably don't even need to do the rest of the formula here or do the other ones using formula. I can go T4 and T5 and then just simply write out the terms. We see that they're all increasing or decreasing in this manner by -2. So I'm going to take this and go -13 and -15, and that's just me just subtracting 2 from each of the next two terms, which gets me further and further. And we can continue that pattern all the way through, either by the formula or just saying, hey, we know that this difference between the terms is -2. All right, now, in arithmetic sequences and geometric sequences, we're going to obviously start with our arithmetic sequences. That's where we're going to begin in this section 1.1. Now, on your formula sheet, you're going to be given the following for arithmetic sequences. You're going to be given this formula, which allows us to calculate any single term, or it represents the general term of an arithmetic sequence. And then in order to figure out a very important piece here, we have this idea of a common difference. A common difference is just this idea of what is the term, or what is the term difference between any two consecutive terms, such that it allows us to go from one term to the next. So that's what we call that common difference, or that common added term or common subtracted term. Now, something you're going to notice here, and something I'd like you to note here, is two things. We know that this is going to be on our formula sheet. So don't feel like you have to memorize this. This is not like a requirement of the course to have this in your back pocket. You just want to essentially be like, hey, as long as I know that these are for arithmetic sequences, then we're good. We can figure this out. The second note I want you to make is that they sometimes will put this a value here instead. So you'll see, like, on a given formula sheet, they'll be like a plus n minus 1d. Well, that's the exact same as the t1 that's written above here. So I just want you to write that below maybe and go t1 is equal to a, such that if you ever see that in like a textbook or any sort of example or even some sort of question that they give you, don't be thrown off. A is just another way of saying, what is t1? All right, now continuing forward here, we're going to take a look at an example two where they're going to give us some sort of sequence. And in this situation, we want to underline this, and we'll go back to this in a second, but there's these three dots and then just nothing after them. And I want to indicate something in a second about that. But for now, just underline that as some sort of important thing we want to keep track of. Now, they tell us what is the first term. The first term is located right here. It's 4. So we're going to write that T1 is equal to 4. That's the first term. What is the common difference? To get the common difference, you just take any two consecutive terms and subtract them. So, for example, I could do something like 10 minus 7. This would be totally fine because this would easily give me that common difference I'm looking for, which is 3. And if you took any of the other terms, you could take 16 minus 13, 7 minus 4. It's all going to give you that common difference of 3, and we're going to indicate this as D in this unit. What are the next three terms in the sequence? Well, if we know that the common difference is 3, that there is 3 being added to the next term, well, 16 plus 3 is going to give me 19. Then we're going to go 19 plus 3, which is 22, and then 22 plus 3 is 25. There you go. There's your next three terms. Now, here's where we wanted to underline those three dots and then go back to, is the sequence infinite, stops at some point, or is it, and I should say finite, sorry, finite and it stops at some point, or infinite goes on forever? It's actually infinite in this situation. And the reason we know that is because as soon as you see these three dots like this, it actually implies that this is an infinite sequence that continues on and on and on with no end. If there was the three dots and then some term at the end, then we would be like, okay, well, they're just truncating it and then saying that there's a term on the end, meaning it's finite. But in this situation, when it's three dots and then there's nothing after it, you know that this thing is an infinite sequence. And so we want to make sure we indicate that here, that this is infinite. Awesome. Okay, now they're asking us, what is the value of T71? Now, to figure out the value of T71, again, this is meaning what is the 71th term in this sequence? So we're going to write it out in the following way. T71 is equal to, well, on our formula sheet, remember, we're going to be given this T1 plus n minus 1 all times the common difference. Now we're going to plug in what we know about this. T71 is equal to 4, which was the first term, plus the n value, which is 71, minus 1 times the common difference of 3. In this situation, if you plug it into your calculator and you figure out what this value is, you end up figuring out that the 71th term is 241, or 214. Okay, perfect. So we're going to highlight that. That's our first important piece of information where, obviously we could write this out algebraically and on pen and paper just go plus 3, plus 3, plus 3, but that would take us like all day. We'd have this massive list and we'd write up all over our paper here. Okay, we're going to go over to F. What is the general term for the sequence? Well, the general term is just saying, hey, if I take Tn, which is the general term, it's defined by T1, which is 4, plus n minus 1, because we don't know what term we're looking for, times the common difference of 3. So it's very, very important that when we put in this general term for the sequence, we have two elements. First of all, we need our T1. The second piece, we need the D value. If you don't have either one of those two, then technically you haven't defined the general term because you're missing too many variables. The only variable we should have is this n value because we don't know which one we're looking for. We're just looking for some value in that sequence. All right, now we're going to use the general term to figure out 252. So in this situation, I'm going to go T, and this is going to be of 152. There we go, which is equal to T1, which is 4, plus, in brackets, the n value, which is 152 minus 1, times the common difference of 3. this is going to end up giving us T152 is equal to 454. So 454 is the 152nd term in this given sequence. All right, now what they're going to want us to do is they're going to say, let's graph out this arithmetic sequence and see what's happening. And we want to label our axes. So always, when we come to graphing these things, we want to put the n value or the term number on the x-axis. That's the input. That's the term we're looking for. And then in terms of the actual value of that term at that number, we're going to put that on our y-axis or our output. And just to make that a little bit neater, I'm going to go a little bit off to the side there. So whatever specific number of term we're looking for goes on the x as the input. So let's say we're looking for the 50th term. Then we would go on the x-axis and go up to the output, which tells us what that number is in the sequence. Now we're going to graph out the list that they gave us above here. It started off where 1 was 4. So we're going to put, whoops, I don't want to have that jump over. We're going to go to 1 and 4, which is here. We're then going to go to 2, and it jumped us up to 7. So it might have to be somewhere between a line. It's right about here. Then we go to 3, and 7 goes to 10. So we're going to put it right here. 4 was at 13, which puts it right here. 5 was at 16, which is going to put it right here. 6 was at 19, which is going to put it here. And then lastly, we have our 7, and then 19 plus 3 would put us to 22. Now, one thing you should notice about this right away is that when we look at this, they're going to ask us, should these points be connected, and explain why? No, they should not be connected because there's no such thing as a 1.5 term in the sequence. Like, you don't have half a term in a sequence. That doesn't even make sense here. So we want to leave these non-connected. And so we're just going to say no connection. And then simply put, below this, you would just be like, there's no 1.5 or even like 2.5 term. This doesn't make sense. That this won't happen where you have like some fractional amount of a term, because we're not going to talk about half terms. That won't even be brought up in arithmetic or geometric. We only have a whole amount of terms. So it's either 1 terms, 2 terms. It's all the natural numbers. We want to stick to that and leave it at that. In other units like relations and functions from Math and C, or even some of the graphing we would have done, when we talk about regular functions, you can have half values, but in this situation, no, we're not going to have half terms. The other detail you're going to notice is that it forms a linear relationship, meaning there is a common difference that remains the same between every single term. So when I go from term 1 to 2 to 3, they're increasing or decreasing by the exact same amount. In this situation, they're increasing, but in other situations, they might decrease. All right, let's go to example 3 and look at this situation. So given the sequence of -3, -10, -17, what's happening between these two? Well, in this situation, they say, is this arithmetic? It is arithmetic. And the reason we can determine that right away is we look at this and we see that the common difference is -7 between every single term. So every new term we jump to, it decreases by this 7. We can do a quick test to determine this. We go, yes, the common difference remains the same. Remains the same. And then in our next part, for part B, they actually ask us, what is that common difference? Well, the common difference in this situation, to determine that, we can take any 2 consecutive terms and subtract them. I'm going to take -10 minus the -3, which was term 1. And again, you could take any 2 terms that are consecutive and subtract them. -10 minus -3 is the same as -10 plus 3. This gives us a common difference of -7. So that's going to be between every single term in this sequence, we subtract 7. Determine T20. Well, to determine T20, again, we need a couple things when we plug this in or when we go to do this calculation. First and foremost, what we need is we need to write out our formula from our formula sheet, where it says that Tn is equal to T1 plus n minus 1 times d. In this situation, we're looking for the 20th term, so we're going to put T20 is equal to T1 was -3 plus 20, which is the number of term we're looking for, at minus 1 times the common difference of -7. This is going to end up giving us, when we plug this into our calculator, that the 20th term in this sequence is -136. And again, you could write this out on pen and paper, just like this expansive list, and you could just go -7, -7, -7, and you would eventually hit this. But like, would you rather just do a quick little formula like this, or be writing it out on pen and paper for the next 10 years, covering half a page doing that. I mean, I know which direction I want to go. So that's the beauty of this unit is we're giving you the power algebraically to solve for terms that are way down the line without actually having to write out this sequence. All right, which term in the sequence has a value of negative 339? Well, this is just essentially saying what is the Tn, or what specific term is this when it is 339? So if Tn, or the term we're looking for, is where it's negative 339, and this is going to be equal to the term 1, which is negative 3, plus, we don't know the n value because that's what we're looking for. It's what term this is, times the negative 7, which is the common difference. I'm just going to algebraically solve this for n. So this is going to be negative 339 is equal to negative 3. This is going to be minus 7n plus 7 when I expand the 7 into the n minus 1. Now, when I combine these, negative 3 plus 7 gives us positive 4. And so let's actually write that next line out. Negative 339 is equal to 4 minus 7n. From here, I'm going to subtract 4 from both sides. And when I subtract 4 from both sides, this is going to give me negative 343 is equal to negative 7n. The last thing we got to do is just divide both sides by negative 7 in order to isolate for this n. And we're going to find that, therefore, the n value when we divide this is equal to 49. So when we get negative 339 in the sequence, it represents the 49th term. That's another way of saying, hey, we have 49 terms in this given sequence when we have this specific value here. Awesome. Okay, let's go to our next example here, which is determine the number of terms in the finite arithmetic sequence. Now, how do we know it's finite? Again, when we look at the triple dots here, we're like, okay, triple dots can either mean infinite or finite, but if we see that there's a specific term after those triple dots, what this means is that this sequence is continuing. We don't include all the values between, we just truncate it, and then we put the very final term here. So just to annotate this here, this is going to be our T1, this is going to be our Tn, or the last term in the given sequence, and then what they're asking for is how many terms are there in this given sequence if it ends with negative 148. Now we're going to write out our formula because our formula is the most important piece. We're going to go Tn is equal to T1 plus n minus 1 all times the common difference of d. Now, what you're going to realize is that we don't have that common difference. So what we need to do is figure it out. We can take any two consecutive terms and subtract them. So I'm going to call this, let's call that just the preliminary step. This is going to be our true step number 1. The common difference is negative 56 minus negative 52. We take any two consecutive terms and subtract them. That means that negative 56 plus 52, I get negative 4 between each of the terms in terms of a common difference. Now we can actually go directly into the formula here. So I'm just going to go maybe to the right here and start it. For step number 2, we're going to write this as Tn, which is equal to negative 148, which is equal to term 1, which is negative 52, plus we don't know the n value, but we now know the common difference of negative 4. Now what we're going to do is just solve this just like we did on the previous page. Negative 148 is equal to negative 52 minus 4n plus 4. Negative 52 plus the 4 is going to equal negative 48 plus 4n. I'm going to add 48 to both sides, so plus 48 and then plus 48. This is going to end up giving me a negative 100 is equal to positive 4n. And then I just want to make sure that, this should be a negative here. I was like, the fact that we're getting a positive there is not good. There we go. We have a negative 4n. We're going to divide both sides by the negative 4, divide by negative 4. And therefore, when we draw it off to the side here, we're going to say, therefore, n is equal to positive 25, or there are 25 terms in the sequence. Perfect. And I'll just truncate it as seq, which is totally fine, but preferably you'd want to write the full thing out. But we see it as there's 25 terms in this finite sequence. Okay. Now let's continue below, and we look at the following example where they say there's two terms in the arithmetic sequence, which are T3 equals 4 and T8, which is equal to 34. What is T1 and T34? Okay, interesting. So we want to figure out two pieces of this, but in order to figure this out, again, we need to figure out some specific details. And one of those specific details is, of course, what is the T1, but we also want to figure out what that common difference is. Now, I'm going to show you two ways of getting the common difference. One is a little bit more applied. The other one is pretty straightforward. So let's say I had T3 and T8. And I want to do the following here, just as a way to possibly solve this. Let's first of all suppose that the T3 is equal to the T1 in this, which is equal to 4. And we're also going to suppose that that T8, if we realize that to go from T3 and make it the T1, we had to go back 2 positions, that means that the T8 is actually going to be the T6, which is 34. Now, to explain what I'm doing before I continue here, I'm essentially treating this T3 and T8 like they're the beginning and some term in that sequence. So it's almost like I'm resetting the sequence so that it kind of makes it feel like this is the beginning of the sequence just temporarily so that we can figure out this common difference. Now, again, here's how we're going to use this. I'm going to look at this and be like, well, T6, which is our final term, or the furthest term, is going to be equal to T1 plus the n minus 1 times that common difference. Well, in this situation, our n value is 6, and the actual value of that is 34 here. So we're going to go 34 is equal to our supposed T1, which is 4, plus 6 minus 1 times the common difference. This is going to give us 34, which is equal to 4 plus 5d. And then we're going to subtract 4, which gives us 30, is equal to 5d. And now I'm just going to simply divide both sides by 5. And when I divide both sides by 5, I end up figuring out that the common difference between all the terms is 6. Now, what I did here is, again, I temporarily reset the sequence so that it looks like I have a T1 and I have some sort of term that I can use, but this isn't actually the T1. This was just a way of helping me figure out what is that given value for this. Now, I just want to double check here in terms of values. Oh, no, we're good. Just making sure that we had the right things here. Okay, so we take 30 divided by 5, we get 6. Now what we want to do is we see that we have some sort of common difference. I'm going to show you the alternative way of getting the common difference, which is the following. So instead, which I'm going to show in blue here, we could do this. So I'll go like method 2. Instead of resetting the sequence or temporarily resetting the sequence, what we could do is we could say, if I take the T8 and I minus the T3 and I divide it by the number of terms between them, well, that's going to average out the number that is between them, or it's going to give me this common difference. How many terms are between 8 and 3? There is a total of 5 terms between those. And so algebraically, here's what I'm going to do. 34, which is T8, minus the 4, divided by 5. Well, this is the same as saying we have 30 divided by 5, and 30 divided by 5, this just simply gives us the 6 that we're looking for. So in this situation, what you can obviously do is just take the average of those terms and the average distance between those terms, or the average when we divide it by the subtraction of those terms will give us that common difference. So if you'd rather just use method 2 and you feel like that's quick, is just taking the one term minus the other and dividing it by how many terms are between them, you'll get that common difference the exact same way as you would if you were to pretend like this is T1 and some term in this sequence. Whatever method you feel comfortable with. I know when you're first learning it, you might default to this, but this is a kind of an interesting way to approach it, is almost to reset the sequence. Okay, so we have our common difference. Perfect. Now, we can actually figure out what the true T1 is and not just suppose a T1 in this situation. So I'm going to move off to the side here and then go, well, in this sequence, we can do this algebraically, or we could just simply be like, hey, to save us a little bit of time, why don't we just use that common difference and work backwards? So I'm going to create 3 gaps here. 1, 2, and 3. In this sequence, we knew that the T3, which was given here, I'm going to label them T3, T2, and T1. T3 in this sequence was given by 4. So if I want to go backwards, well, if I know the common difference was that we add 6, to work backwards, I'm just going to go the other way and subtract 6. 4 minus 6 gives me negative 2. Negative 2 minus 6 gives me negative, and negative 8 here. Perfect. There we go. I was going to say, I think in my notes I might have it currently wrong, but in here we're good. So for this one here, we have 4 minus 6 gave us negative 2. Negative 2 minus the 6 gave us the negative 8. So therefore, our true term 1 is negative 8. And we could write that below and say, therefore, T1 is equal to negative 8. Now, again, we could have used a formula to figure this out, but honestly, if it's only 2 terms away, why don't we just work backwards and just subtract that term? Or if it was adding, or if it was subtracting, we add, just whatever it's going to be. Okay, Now for step number 3, we're going to figure out what that actual T34 is. The T34, we're going to use our formula. So T34 is equal to term 1, which is -8, plus 34 minus 1, all times the common difference of 6. Now what we're going to do is go T34 is equal to -8 plus 34 minus 1 is 33. 33 times 6, we may need a calculator for this one here to actually figure out this value here. So I'm just going to pull one up here and then get our value all combined together. So first and foremost, we're going to take 33 and multiply it to 6, which gives us 198. And then if we take 198 and we minus 8 from here, that's going to end up giving us that this is positive 190. So in the end, our 34th term should be 190 here. Awesome. Okay, now again, you can use whatever method you want. You can either pretend to reset the series and then figure out the common difference from there. You can use the average or take the subtraction and then divide it by the terms between them, and that will also give you that. And then just think logically, and you could either use the formula, or if it's a close enough term, just work backwards algebraically, and that will be totally fine here. Okay, now for a bit of a different one here, they're going to give us terms in a sequence that are in an arithmetic sequence. So that's an important thing, is that there's going to be a common difference here. They say find the next 3 terms, or find the missing terms that would occur after these ones. Now, to determine that, simply put, all we need to do is figure out the common difference. And to do that, just take any 2 adjacent terms, or any 2 that you want to compare. So we could take these 2, we could take these 2. For simplicity, I'm just going to take the first 2 and figure out the common difference. So let's say that this is T1, this is T2, and this is T3. Well, to determine the common difference, we go common difference is equal to the T2 minus the T1. In this situation, that's the same as saying, well, we have T2, which is x plus 3y, and we're going to subtract away T1, which is 4x minus 2y. And it's important you put it all in brackets, because clearly the signs are going to change here. Now, this gives us x minus 4x is negative 3x, and then 3y minus 2y is the same as plus 5y. Our common difference between all the terms is given to us by this here. So every new term we get, we have to subtract 3x's and add 5y's. So let's do that. Negative 2x minus 3x's is going to give us negative 5x. 8y plus 5y gives us plus 13y. Perfect. We have our third term in the sequence. Okay, let's do that for the next one. Negative 5 minus another 3 gives us negative 8x. 13 plus the 5 gives us positive 18y. Okay, so we have T4. Now for our last one, we're going to take 8 minus 3 gives us negative 11x. 18 plus 5 gives us positive 23y's. And there you go. There's your second, or sorry, not your second, but your third, fourth, and fifth terms in this sequence. And again, when you start to see these ones, it looks a little complex, because you're like, wait a minute, like we're talking about x's and y's and there's no specific value. Just figure out that common difference, especially when they tell you arithmetic. Figure out that common difference and then just add or subtract by whatever is necessary. And just be very careful when you're subtracting the terms when they're in these binomial formats like this. Make sure that you have brackets around the terms that you're subtracting or adding, just to make sure that it's clear. All right. Now, in this situation, we're going to go down to an applied example, which is going to deal with some sentence structure and then pulling that apart and figuring out some specific value in here. So in this theater, or this amphitheater, it has 25 seats in the second row, 65 seats in the 7th row, and then the last row, whatever that row is, has 209 seats. The number of seats in the rows produces an arithmetic sequence. So as we go up from row to row, they increase by the exact same amount. How many rows are there in this, how many rows of seats are there in this amphitheater? So we're essentially trying to figure out what is the n value, because the n value determines how many rows there are. The Tn is represented by this 209, and that's saying how many seats are in the final row. So let's write out all that information we have just to organize it. They said in the second row, or T2, this gave us 25 seats. In the T7, or the 7th row, this ended up giving us 65 seats. And then in the Tn, or in the final row, this was 209. Now, our goal is to figure out this n value, because we want to figure out how many rows there are. Now, again, we could use our reset method, which, let's just write that out here. One method, and I'm going to call it method number 1. We could just write out that sequence and be like, okay, let's reset it so that T, and we're going to just write it in the way we did before. Suppose T2 is equal to T1, which is equal to 25. And then we're going to suppose that T7, which is equal to go from 2 to 1, we had to go back one position, meaning this would be the T6th in our resetted sequence, and this would be equal to 65. Now we can figure out what this D is. So we're going to go T6 is equal to T1 plus 6 minus 1, which is the n value, times the common difference, which is what we're looking for. T6 is 65, which is equal to 25 T1 plus 5D. 65 minus 25, this is going to end up giving us 40, which is equal to 5D. We divide both sides by the 5. And this is going to end up giving us that the common difference, or that there is an increase in 8 seats per every given row we go up. So that's an important detail that we get from here. Now, of course, that's method 1. That's if we use our reset method. If we wanted to use method 2, which I'm going to do in blue again, method 2 is just simply saying, hey, we can take the difference between these two terms of T7 and T2, divide it by the common, or divide it by how many terms are between them, and it will give us how much the increase by. So method number 2, we're going to take T7 minus T2 and divide it by the number of terms between them, which is 5. This is going to take us as 65 minus the 25 divided by the this 5, which is the number of terms between them. This is the same as 40 divided by 5. And of course, 40 divided by 5 gives us 8. So therefore, the common difference is 8. Now, algebraically, you can actually see that we're actually doing the exact same thing here. Whether it be the method 1 or method 2, you're subtracting 25 from the last term, then you're dividing it by this term that comes from inside the brackets, which is 5 as well. But however you want to think about it, method 1, method 2, later in university, I really like this method, when you start dealing with more applied math and just wanting to really show your work. But if you take a lot of stats courses, sometimes this method is a little bit better. You'll see later down the road, but whatever method you decide to go with, I would be happy with either one. Now, that's to figure out the common difference, which is very important. That's technically step number 1. Step number 2 is let's just figure out what this n value is. So Tn, which is 209, is equal to the first term in the sequence, which in this situation, we don't know what that T1 is. So maybe we should just take a second before we actually go into this formula to figure out T1. And I'll organize it in the following way. Let's make this step number 1. This, which we're going to hold off on just for a second, I'm going to make step 2 figuring out T1. T1, well, if T2 is 25 and each row goes up by 8, that means that T1 is actually 8 less than 25. 8 less than 25, that puts us at 17. So the first row in the amphitheater has 17 seats. Now we can do our final step here. We can go Tn, which is equal to 209, which is equal to the T1, which is 17, plus the n minus 1. N is what we're looking for. Common difference, which is 8. We're going to multiply this out. So it's 209 is equal to 17 plus 8n minus 8. 17 minus 8, this is going to give us 209, which is equal to 9 plus 8n. We're going to subtract the 9 from both sides, minus minus, and this is going to give us 200 is equal to 8n. We divide both sides by 8, and when we divide both sides by 8, we end up figuring that when we take 200 divided by 8, therefore, n is equal to 25. There are 25 rows in the, hopefully I have enough room here, theater. And I'm going to short form it as that in just the feet, which I don't really like doing, but there you go. So 25 rows in this amphitheater. Awesome. Okay, now here's where you're going to want to go on to the practice problems. So you have your assignment, which is in the bottom, your textbook problems. If I have any additional work for you, I'll give it to you, but you want to move on to assignment 1.1 in the textbook and just try this out, because there's a couple things within this lesson, such as common difference and, dealing with these more applied problems, and then dealing with ones like these where it's like, it's a little bit more ambiguous in terms of like, you're not dealing with specific numbers, but rather you're dealing with like almost algebraic terms. You want to look at these and get some practice with these. So good luck with your practice. And then if you have any questions, let me know.